Hello everyone, welcome to Unravel Logic YouTube channel. In today's video, we will be covering the concept of degrees of freedom. There are no prerequisites for this, so let us dive right in. As usual, let us start with the definition first. Degrees of freedom are the number of values in a calculation that are free to vary once certain totals or constraints are fixed. Number of values in a calculation that are free to vary once certain values or totals are fixed. In other words, how many independent pieces of information you really have. How many independent pieces of information you really have in your data. Let us understand the formula first, and then we'll understand more about this concept. Right? So it would be a little confusing at this point, but once we go ahead with the examples, you will get all the understanding that you need to have for degrees of freedom. So let us see the formula first. General idea is that degrees of freedom, commonly denoted as df, are nothing but number of independent pieces of information for one variable with categories. Consider a die. So it's one variable which can take 6 values. So those are different categories, but fixed values, and that's the reason categories. So it can take a value from 1, 2, 3, 4, 5, 6. So there are 6 categories for that die, which the values that it can take. So for that, df, or degrees of freedom, is number of categories minus 1. So if a die can take 6 values or 6 categories it has, so the degrees of freedom for a die will be 6 minus 1, that is 5. Okay, and let me actually erase that, and 5. Okay, so if we look at the definition, what it means is that you can choose 5 values freely, and the last one that would be remaining would be the 6th value that would be evident from the other 5 values that you've already chosen. Yeah, so that is the reason degrees of freedom is 5. So you can choose 5 values freely. Now for two-way tables, okay, for two-way tables, and we would cover what two-way tables mean in this video itself, and then you would understand more. So for two-way tables, which would typically have rows and columns, the DF or degrees of freedom would be rows minus 1, number of rows minus 1 times number of columns minus 1. That would be degrees of freedom. Now let us understand the mathematical intuition using examples for each of these things that we just considered in the formula. So mathematical intuition. So let us take an example of one variable. Let us say that we have a bill of $60. Bill for a restaurant, and we need to find the possibilities of how we can split that bill into amongst 3 friends. So we have 3 friends, and let's say we split $20 for friend A, we split $25 for friend B, and the friend C would automatically get $15 because that is the remaining amount out of $60. Because you already allotted 20 and 25 to friend A and B, then the only remaining amount, that is $15, goes to C. So this was evident given that we knew the split for A and B. Okay. So we saw that we were free to choose the values for 2 friends, and we can do that for any 2 friends, okay, whether it can be A or C, A or B, yeah. And we were free to choose the values for 2 friends, and the third one got automatically derived because that was the remaining amount, yeah. So what this gives us is, if there are k values and they must add up to one total, all the values add up to one total, that is 60 in our case, then k minus 1 are free to choose, yeah, k minus 1. So we had 3, so k is equal to 3, so we were able to choose 3 minus 1, that is 2 values freely. That is what it means, and this is what happened in our example. Now let us take another example for two-way tables. As I mentioned that I will be explaining this in detail. So two-way tables. Imagine that, or suppose, yeah, because we are not imagining, we are actually having it. So suppose we have a two-way table with color and genders, male or female, and we have a few colors. So let me create the table first quickly. So this is the table that we have been given, and the question marks are the values that we need to find out. Okay, we need to guess basically. Okay, so let me explain what two-way tables are. So two-way tables are a useful way to arrange data between two variables with different categories. So we have two variables. Which two variables? We have let's say we have gender here, and then we have a color here. So we have two variables, and each of these two variables have different categories. So gender has two categories, male, female. Color has three categories, red, blue, and green. No matter how many categories we have, but those categories should belong to any of the two variables. The variable should be two, and that is the reason it is called as two-way tables, because only two variables we can assign in a two-way tables, and that would be meaningful in a meaningful way basically. So these are two-way variables, and these two-way tables are very insightful and a very nice way to arrange such kind of variables which can have different categories, because if you see, it can give you a lot of information. For example, if you want to find out how many males like the color red, and this would give you that number. For example, how many females like the color green, so that would be the value. Okay. How many people like the color red, so this would be the value. Okay, so it gives you a lot of information if you arrange that data in a tabular form like this. So the degrees of freedom for this is given by df equal to r minus 1 and column minus 1. So number of rows minus 1 times number of columns minus 1, which in our case equals to 2 minus 1 times 3 minus 1. That gives us 2. So we got degrees of freedom is 2, but what does it actually mean in this particular case, or in case of two-way tables? So what it means is that if I am able to find the values of any two cells, for example this or this, then I will be able to find the values of other cells automatically. So if I find out these two cells, then I would automatically get the values of this cell, this cell, this cell, this cell, because I have all the other values now to calculate these remaining values. Okay, so this is what degrees of freedom means here in a two-way table, and that is how you find out. So basically, if I were to rephrase the question, that given this table, how many minimum values I need to calculate or find out, using which I can calculate all the other values. Now you might be wondering, why would you ever do this? Yeah, but that would come in the later videos, because we'll be dealing with a lot of different types of statistics which would help us in predicting these values, and degrees of freedom would be very useful in those cases. So that is the reason I am covering this topic first. But yeah, in essence, this is what degrees of freedom means. Okay, now what you need to also notice that more degrees of freedom means that there are more chances of variation in your data. Because if the amount of variables or categories that you are free to choose will increase, then you can say that there would be a lot more variation, because you can choose those categories in a different ways. So the more those categories are, or more the degrees of freedom are, the more variance would be there in your data. We already covered the concept of variance, so you understand what I mean, right? So there would be a lot more variance in your statistics. That is what it means. So more degrees of freedom means that there are more chances of variation in your data, and knowing that will help you in analysis, a lot of analysis in your statistics. Okay, so this is basically a prerequisite for the concepts we'll cover in upcoming videos, and that is when you will understand when to use it. why this is important is the part that you will understand when we cover when we cover different concepts in later videos, and this concept will be used in those concepts. Okay, so thank you for watching. Please like, share and subscribe. Also comment to give your feedback so that it motivates me to create more such videos and improve wherever the improvement is required. Okay, thank you. Thanks a lot.